Before we go any further, I need to correct the premise of that headline directly, because being honest with you matters more than a dramatic hook. Cassini's final images weren't captured 3 minutes ago. They were captured on September 14th, 2017, nearly a decade ago now, in the final hours before NASA deliberately flew the spacecraft directly into Saturn's atmosphere and let it burn up on purpose. But the real story behind those final images is genuinely worth telling properly, because it's one of the most quietly emotional moments in the entire history of space exploration. A 20-year mission that ended with a spacecraft taking one last look around at everything it had spent 2 decades getting to know before NASA's own engineers deliberately destroyed it, on purpose, to protect something they thought might be more important than the mission itself. This is the true story of Cassini's actual last images, why NASA chose to end the mission this way, and what happened in mission control during the spacecraft's final 30 seconds. If you want the accurate version of space history instead of manufactured urgency, subscribe now, because this story deserves to be told correctly. Let's start with why Cassini existed at all, because the mission's actual scale gets lost when people only focus on its dramatic ending. Cassini launched on October 15, 1997, a joint mission between NASA, the European Space Agency, and the Italian Space Agency, and spent 7 years traveling before finally arriving at Saturn in 2004. Once there, it spent the next 13 years in orbit, studying the planet, its rings, and its sprawling family of moons in a level of detail no previous mission had ever come close to achieving. Cassini discovered active geysers erupting from the south pole of Saturn's icy moon Enceladus, jets of water vapor and ice particles blasting out into space from what scientists eventually confirmed was a genuine subsurface ocean, one of the most significant discoveries in the entire search for potentially habitable environments beyond Earth. It carried a separate probe called Huygens, which detached from Cassini and became the first human-made object to successfully land on a moon in the outer solar system, touching down on Saturn's giant moon Titan and revealing a genuinely alien landscape shaped by lakes and seas, not of water, but of liquid methane and ethane. It's worth spending a bit more time on exactly what Cassini found at Enceladus, because that single discovery is really the reason its entire final act had to be handled so carefully. In 2005, Cassini's cameras spotted something nobody expected from a small Psi moon barely 300 miles across, plumes of water vapor and ice particles erupting from cracks near its south pole, venting directly out into space. Follow-up flybys, some of them daringly close, allowed Cassini to actually fly directly through those plumes and sample their composition with its own instruments, eventually confirming the presence of organic molecules and, remarkably, molecular hydrogen, a chemical signature strongly associated with hydrothermal activity, the same basic kind of chemistry that powers ecosystems clustered around hydrothermal vents deep in Earth's own oceans, far from any sunlight. That discovery transformed Enceladus almost overnight from an unremarkable ice moon into one of the single most compelling places in the entire solar system to search for potential life beyond Earth. A moon with a genuine subsurface ocean, real organic chemistry, and a plausible energy source, all confirmed directly by a spacecraft that had originally been sent to Saturn primarily to study the planet and its rings. By 2017, Cassini had been operating for 13 years at Saturn, far longer than its original mission plan, and it was finally running critically low on the fuel needed to keep adjusting its orbit. That created a genuinely serious problem for NASA's mission planners, one with real stakes attached to it. An out-of-fuel spacecraft, left drifting in orbit around Saturn indefinitely, would eventually become uncontrollable, and there was a real risk that its orbit could eventually decay and cause it to crash into either Enceladus or Titan, the two moons Cassini itself had helped identify as genuinely promising candidates for hosting life. NASA's planetary protection policy exists specifically to prevent exactly that kind of scenario, contaminating a potentially habitable world with Earth-based microbes that might have survived, undetected, on a spacecraft's surface for decades. Rather than risk that outcome, NASA's team made a deliberate decision years in advance to end Cassini's mission by intentionally flying it directly into Saturn itself, where the planet's own atmosphere would destroy the spacecraft completely, ensuring it could never contaminate either moon. The Huygens landing itself deserves a bit more detail too, because it remains one of the most remarkable individual achievements of the entire Cassini mission on its own. After separating from Cassini in December of 2004, the Huygens probe spent roughly 3 weeks drifting alone through space, before finally reaching Titan's dense orange atmosphere in January of 2005, descending by parachute for about 2.5 hours before touching down on the moon's actual surface, an achievement that remains, to this day, the most distant landing any human-made spacecraft has ever successfully accomplished anywhere in the solar system. The images and data Huygens managed to send back during its brief working life on the surface revealed a landscape that looked eerily familiar and utterly alien all at once. Drainage channels apparently carved by flowing liquid, rounded pebbles suggesting erosion by moving fluid, and a surface chemistry built almost entirely around methane and ethane rather than water. An entire world operating on hydrocarbon chemistry at temperatures roughly 290 degrees below 0 Fahrenheit. Cassini itself continued studying Titan from orbit for the following 13 years, using radar to peer through the moon's thick haze and eventually mapping out entire seas of liquid methane large enough to be visible from space, one of which, called Kraken Mare, turned out to be larger than any of the Great Lakes here on Earth. If a story built on real, verified NASA reporting instead of exaggeration is the kind of thing you want more of, drop a like on this video right now. It genuinely helps this content reach more people who get value out of it. It's worth understanding exactly which instruments captured those genuinely final images, because Cassini didn't rely on a single camera to build its last look at the Saturn system. The spacecraft's imaging science subsystem, consisting of both a wide-angle and a narrow-angle camera, handled the visible light photography that made up most of the scrapbook sequence, while a separate instrument, the composite infrared spectrometer, captured the thermal infrared data showing heat radiating from deep within Saturn's own atmosphere. Combining data from multiple instruments this way wasn't unusual for Cassini, which carried 12 separate scientific instruments in total throughout its mission, but doing so during these final, carefully sequenced observations meant mission planners had to coordinate exactly when each instrument would point where, ensuring the spacecraft's limited remaining time and data storage were used as efficiently as possible before the mission's inevitable end. It's also worth remembering that Cassini's own name traces back to an even earlier chapter of Saturn's own exploration history, one connecting the spacecraft to more than 3 centuries of observation. The mission was named after Giovanni Domenico Cassini, a 17th century Italian astronomer who first discovered the prominent gap now known as the Cassini division, a genuine visible gap within Saturn's ring system, carved out by the gravitational influence of the moon mimas, visible even through comparatively modest telescopes from Earth. The spacecraft that eventually bore his name spent 13 years studying that same ring system, and the gap Cassini first identified from Earth centuries earlier in extraordinary close-up detail, revealing structures within the rings that no ground-based telescope could ever have resolved, waves and ripples propagated by the gravitational tug of nearby moons, and the ongoing active process of ring material slowly raining down into Saturn's own atmosphere that the grand finale's final orbits helped directly confirm. The grand finale dives themselves weren't just a symbolic send-off either. They produced genuinely important science that Cassini's more cautious earlier orbits had never been able to attempt. Threading the narrow, roughly 1,500-mile gap between Saturn's cloud tops and the inner edge of its rings meant flying through a region mission planners had spent years worrying might be filled with ring debris capable of seriously damaging the spacecraft, a risk considered acceptable specifically because Cassini was already on a one-way trip toward destruction regardless. Those 22 dives allowed Cassini to directly sample the composition of Saturn's uppermost atmosphere and the material actually falling from the rings down into the planet itself, confirming a phenomenon scientists had theorized about but never directly measured: ring material continuously raining down into Saturn's atmosphere, slowly eroding the ring system over time. The dives also let Cassini measure Saturn's internal magnetic field and gravitational field with far greater precision than any previous orbit had allowed. Data that helped researchers refine estimates of the length of Saturn's day, a surprisingly difficult figure to pin down precisely for a gas giant with no solid surface to track, and helped narrow down the actual mass and structure of the ring system itself. It's worth appreciating just how genuinely international this entire mission actually was, because Cassini's final images represented the culmination of a collaboration spanning multiple countries and space agencies working together for decades. Beyond NASA's own leadership, the European Space Agency contributed the Huygens probe itself, along with numerous European research teams who spent years analyzing the data it returned from Titan's surface, while the Italian Space Agency provided Cassini's high-gain antenna, the exact piece of hardware responsible for transmitting every single image and measurement, including those genuinely final frames, across the vast distance separating Saturn from Earth. 17 different countries contributed instruments, funding, or scientific personnel to the mission over its lifetime, a genuinely global scientific effort that makes the mission's ending feel considerably less like a single American space agency losing a spacecraft, and considerably more like an international scientific community collectively saying goodbye to a shared, decades-long undertaking that had employed and inspired researchers across the entire world. That ending became known as the grand finale, and rather than treating it as simply an unfortunate necessity, Cassini's team turned the spacecraft's final months into one last deliberate science campaign. Beginning in April of 2017, Cassini started a series of 22 increasingly daring dives through the narrow, previously unexplored gap between Saturn and its innermost rings, a region no spacecraft had ever attempted to fly through before, gathering unprecedented close-up data about the planet's atmosphere, its magnetic field, and the composition of the rings themselves. On April 12, 2017, during that same period, Cassini captured what would become its last ever view of Earth from the Saturn system, a small, pale point of light lost in the vastness surrounding the ringed planet. As the mission's actual end date approached in September, Cassini's team made a conscious choice to spend the spacecraft's final days revisiting the objects and places that had defined its entire 13-year mission, one last time. Linda Spilker, Cassini's project scientist at NASA's Jet Propulsion Laboratory, described the approach in a way that captures exactly how the team was thinking about those final days. She compared it to taking one last look around your own house just before moving out for good, walking through each room, running your fingers along a familiar banister, letting old memories come flooding back with every step. On September 13, 2017, Cassini's cameras captured what the team referred to internally as its scrapbook images, a deliberate farewell tour of its favorite subjects from 13 years of exploration. It photographed Saturn's rings in exquisite detail, including the small moon Daphnis, creating visible ripples in the ring material as it moved through a narrow gap. It captured a haunting image of the icy moon Enceladus, the very world whose hidden ocean Cassini itself had discovered, appearing to set behind the enormous curve of Saturn in the frame. It photographed Titan one final time, its thick, hazy, orange atmosphere glowing softly. The same moon where Cassini's own Huygens probe had landed 13 years earlier. And it captured Saturn's northern hemisphere itself, the destination the spacecraft was now heading toward for the very last time. If you found this as moving as I did while researching it, drop a comment and let me know. It genuinely helps me figure out what to cover next. The following day, September 14, 2017, at 12:59 p.m. Pacific Time, Cassini captured its actual final images, the very last photographs the spacecraft would ever take before its instruments went silent for good. Unlike the sentimental farewell tour captured the day before, these final frames served a genuine scientific purpose, right up to the last possible moment. One final image, captured using Cassini's visual and infrared mapping spectrometer at a wavelength of 5 microns, showed Saturn in thermal infrared, heat radiating outward from deep within the planet's interior, glowing in shades of red, with dark cloud bands silhouetted against that inner warmth. Marked within that image was a specific white ellipse, showing mission planners exactly the region of Saturn's atmosphere where Cassini itself would plunge to its destruction roughly 14 hours later. Cassini's final visible light image, captured at the same moment, showed a quiet, nighttime view of Saturn's atmosphere, illuminated only by faint sunlight reflecting off the planet's own rings, marking the precise location where the spacecraft's own journey was about to end. Then, having gathered every last piece of data it possibly could, Cassini turned its main antenna to keep transmitting continuously back toward Earth, and began its final descent. In the early morning hours of September 15, 2017, the spacecraft plunged directly into Saturn's upper atmosphere, still actively transmitting real-time scientific data about the composition of that atmosphere as it went, right up until atmospheric friction and heat finally tore it apart completely. According to NASA's own mission records, Cassini's last signal was received on Earth at 4:55 a.m. Pacific time that morning, and in a small, quietly remarkable detail that the mission team specifically noted afterward, the spacecraft actually survived roughly 30 seconds longer than engineers had originally calculated it would, continuing to transmit real data for slightly longer than anyone had actually expected from a spacecraft being torn apart by atmospheric entry at that exact moment. It's worth noting that Cassini's deliberate planetary protection-driven ending wasn't actually the first time NASA had made this exact call for a mission at a gas giant. Years earlier, in September of 2003, NASA's Galileo spacecraft, which had spent 8 years studying Jupiter and its own family of moons, was deliberately flown directly into Jupiter's atmosphere for essentially identical reasons, specifically to eliminate any possibility of the spacecraft eventually crashing into and contaminating Europa. A moon Galileo itself had helped confirm likely harbors a subsurface ocean of its own. Cassini's own grand finale was, in a very real sense, built directly on the precedent Galileo had already established. A recognition within NASA that once a spacecraft's own discoveries identify a genuinely promising target in the search for life, protecting that target from contamination has to become part of how the mission itself eventually gets brought to a close, rather than an afterthought handled once the fuel simply runs out. In the mission control room at NASA's Jet Propulsion Laboratory, the team that had spent 20 years of their careers in many cases working on this single mission watched the signal simply stop. According to reporting from the scene that day, the room responded with a mixture of applause, hugs, and open tears An entire team simultaneously celebrating one of the most successful planetary missions in the history of space exploration, while genuinely grieving the loss of a spacecraft that had, in a very real sense, become a working companion to hundreds of scientists and engineers over the better part of 2 decades. It's worth being clear about why NASA structured the mission's end this way, rather than simply allowing Cassini to run out of fuel and drift silently, because the decision reflects something genuinely thoughtful about how the agency approaches the broader responsibility of exploring other worlds. Enceladus, with its subsurface ocean and active geysers, and Titan, with its complex organic chemistry and liquid hydrocarbon seas, both remain among the most scientifically important targets in the entire search for life beyond Earth, precisely because of what Cassini itself discovered there. Deliberately destroying the spacecraft that made those discoveries, specifically to protect the 2 worlds it had found so fascinating from any risk of contamination, carries a kind of built-in irony that mission planners were fully aware of at the time, and one that Cassini's own science team has spoken about directly in describing why the grand finale was designed the way it was. There's one more part of this story worth including before we wrap up, because Cassini's actual scientific legacy didn't end the moment its signal went silent over Saturn. The spacecraft spent 13 years at Saturn returning an enormous volume of images and instrument data, and researchers have continued mining that archive for new discoveries in the years since the mission officially ended, refining models of Saturn's interior, studying seasonal changes across the planet's atmosphere, captured over more than a decade of continuous observation, and continuing to analyze the detailed chemistry Cassini sampled directly from Enceladus's plumes. In that sense, Cassini's actual final act of discovery wasn't really the single set of images captured on September 14, 2017 at all. It was simply the last time the spacecraft itself was able to add anything new to an archive that scientists are to this day still working through nearly a decade after the mission's fiery, deliberate ending. It's worth adding a bit more detail about exactly what that continued research has actually produced in the years since, because Cassini's data archive has kept generating genuine headline-worthy discoveries well after the spacecraft itself stopped transmitting. Researchers analyzing gravity measurements gathered during those final grand finale orbits refined estimates of Saturn's core, suggesting it may be considerably larger and more diffuse than earlier models predicted, a genuinely significant revision to basic planetary science that only became possible because of the exact close, daring passes between Saturn and its rings covered earlier in this video. Separate teams have continued studying seasonal changes in Saturn's massive hexagonal storm at its north pole, a genuinely bizarre 6-sided weather pattern first properly characterized using Cassini's own long-term observations, tracking how its color and behavior shifted across the many years the spacecraft spent watching it evolve. That kind of ongoing scientific productivity, years and even a full decade after a mission's official end, reflects something worth appreciating about how modern space exploration actually works. The value of a mission like Cassini rarely gets fully realized the moment its last image is taken, but instead continues accumulating for as long as researchers keep finding new questions to ask of the same carefully preserved dataset. There's a small specific detail from that final press conference worth including as well, because it captures something genuinely rare in how NASA typically discusses the end of a spacecraft's working life. Journalist Leah Crane, reporting from the scene as Cassini's last signal was received, described the mood in the room directly, noting that Linda Spilker's own comparison, walking through your own house one final time before moving out, running your fingers along a familiar banister, wasn't simply a poetic flourish added for the cameras. It reflected how genuinely personal this particular ending felt to a team that had, in many cases, spent the better part of their entire careers working on this single spacecraft, from its 1997 launch through 13 years of active exploration at Saturn, arriving finally at a deliberately engineered ending that the team itself had spent years planning and, by every account from that morning, still found genuinely difficult to actually watch happen. So, what does all of this actually add up to? Cassini's genuinely final images weren't captured minutes ago, they were captured on September 14th, 2017, showing Saturn's atmosphere both in visible light and thermal infrared, marking the exact patch of sky where the spacecraft itself would disappear less than a day later. Those images came at the end of a deliberate, carefully planned farewell tour through the Saturn system, one last look at the rings, at Enceladus, at Titan, and at Saturn's northern hemisphere, captured by a mission team that treated the end of a 20-year spacecraft's working life with the same kind of care and attention they'd given to every other phase of the mission that came before it. When Cassini's signal finally went silent on the morning of September 15th, 2017, having survived 30 seconds longer than anyone expected, and having transmitted genuine scientific data about Saturn's atmosphere right up until the very last possible moment, it brought to a close one of the most productive and consequential planetary missions humanity has ever launched, ending not with a slow fade into silence, but with one final deliberate act of discovery. If stories like this, the real, accurately dated version rather than manufactured urgency, are what you come here for, subscribe to this channel and turn on notifications, because there's a lot more real space history still worth telling correctly. Thanks for watching, and I'll see you in the next one.